My name is Sherry Fong, and with me here today is Paul McLeod from System Product Management Team. In this webinar, we will be looking at the latest updates, solutions, and applications in top-loading storages. The presentation will take about 30 to 45 minutes, and afterwards, there will be time to answer any questions you may have. So if you have any questions, please submit the questions through either the chat or the Q&A features at your end. So right now, I will just hand the microphone to Paul. Let's welcome Paul. Thank you.
Okay, thank you, Sherry. So yes, as Sherry mentioned, my name is Paul McLeod. I am product director here at Supermicro, responsible for storage servers. So without further ado, I'll just kind of jump into our presentation. So many of you have probably seen this over the years. This is kind of the categories that we will, categorize our storage servers on the SSG team. So you'll hear SSG used in my presentation. SSG is basically Super Storage Group. So we're a subgroup in the system team and responsible for essentially high capacity storage servers. So as you can see on this, we have multiple categories from cloud scale to enterprise optimized to petascale. And today we're going to be focusing on the cloud scale and specifically the top loading line, because the top loading line is, again, sort of an industry standard, and it's one of the areas that is of very specific interest to anyone doing or requiring extremely dense storage servers. So this is a great product, and again, we're into our second generation of product with storage server, top-loading storage servers. If you look at the market where these storage servers are being used, there's a broad category of workloads and performance, and really in terms of the applications that specifically fit, these tend to be capacity focused and less concerned about latency performance. So if we see the slide and the performance to the right-hand side of the screen is really where you're starting to get into where latency is the most important thing. So low latency, today that would be NVMe type devices, because again, really the applications give a competitive advantage for the customer, especially if, say, things like this financial trading, if they are extremely low latency, able to deliver the data as quickly as possible. So the broad, in terms of how the industry talks about these, typically are application characteristics or application tiers. And when you're talking about the very low latency time to data, it's a hot tier. The Supermicro super storage portfolio can pretty much cover all these areas, with the caveat that really it is the focus of the product is on capacity. So when we go up into that hot tier, we're talking about all flash and very high capacity all flash. And depending on the application, the capacity requirements may be, extremely exceeded. But if you're looking at cloud scale, then that would be, the appropriate fit. And then right in the middle there is the warm tier. And again, this is something that really, depending on the categorization of the customer's application, many products will fit in this category. Our focus is really in content delivery in the warm tier. And with that, our Simply Double is kind of a sweet spot. And then finally, cold tier, and right edging up against that warm tier, in many cases it is the warm tier for people, is our top loading line. So really, you've probably seen this characterized in pyramid form. And this is how we're doing it this year. But again, many ways to characterize the performance of a storage platform and how our products fit into that metric. So the other way that you can think of this in terms of sales is a focus on cost per gigabyte versus cost per IOP. A flash platform, in terms of its price per gigabyte, is extremely high compared to a spinning drive. And if the application is not needing the kind of latency performance of an NVMe or an SSD, the spinning drive can provide that kind of service. An example of this would be something like media entertainment in an edit suite. Probably not cost effective if they have to store large files in a very expensive flash storage server. Maybe better to use something like Simply Double or the top loading for those kind of files, because again, cost being quite a bit higher in flash. Of course, everyone would love to store everything in flash, but at this point in time, the delta between flash and spinning drives is pretty significant. And the vendors who are delivering spinning drives are really doing everything in their power to try to extend that life. So this is things like dual actuator drives and larger flash caches on the drives themselves. So a lot of that kind of stuff we're starting to see coming out, and it's something that I'm not going to really touch on today because I really want to focus on the storage hardware, but that's something to also be aware of if someone is right at that threshold of capacity and performance. Another sort of positioning category here would be kind of enterprise and traditional enterprise against kind of a cloud model. Cloud has really changed how people buy their storage resources, providing metrics that are abstracted from the physical servers. In the past, you would buy a storage silo from a major vendor, and it would be, it wouldn't be an operational cost type metric. We support both. We support OEMs. We support a huge number of software-defined vendors. And then the applications that typically fit for the top loading line are things like backup, archive, cloud storage, object storage, and then as mentioned before, content delivery. So the cloud paradigm, as I was stating, is pretty much one of the things that really introduced Supermicro into the storage market, right? There used to be an expression, the serverization of storage, and that is really what has occurred in the past 20 years, is storage going from a embedded, dedicated device where all it did was store data to something that is more loosely defined. And one of the main characteristics in terms of how cloud integrated with that is really a move from a scale-up architecture to a scale-out architecture. So really, when you look at what the cloud vendors had to do in order to serve their customers, is create abstraction and create something that could scale performance as it grows, and grows way beyond the margins of some single appliance type architecture. So this is where Supermicro really started to move storage and servers as storage servers. So one of the other big things with cloud is kind of how you talk to your customers, right? So the discussions about the hardware that they're buying to meet their compute and application requirements really became about operational decisions and what was required for those cloud-defined and software-defined environments to work with them. And again, it's been a good number of years, so this kind of discussion is mature. Most of the enterprises out there understand that they will be using probably a hybrid use case moving forward, leveraging public cloud when it's applicable, when it's a good decision, and then also bringing some of that storage back to their own data center, because again, cost values as things grow, you basically have to keep an eye on it. One of the things that this provides for a reseller is really that you need to be closer to your customer in those discussions. You have the opportunity to stay really close to your customer because there's a lot more decisions for them to make in these decisions, and that gives you the opportunity of being that consultant and being that expert for them in picking storage and helping them navigate all of the questions that they'll have about storage. The role of the hardware, again, which Supermicro is best of breed hardware, is basically to stay on the edge of that performance, right? And have the feature set to allow them to manage that storage footprint wherever it might be. And so that could be a different decision, a different architecture based on where it is, what the crew, what the operation looks like in that location. So in a remote branch office, they might have part-time one technician, whereas in a data center, they may have 10 people that are managing the storage. So that there is many decisions that can be made about that. One of the things that we focus on is our open compatibility and our ability to work with the software-defined vendors out there. So whether we sell through an OEM, someone that's taking our server, putting their name on it, we sell that way. We also sell with meet in the channel where you would buy your software and essentially integrate it yourself. So again, a diverse go-to-market is really the focus for our hardware and decisions we make in our hardware architectures. And then of course, the other best of breed is, the technology that we put into it. So you always see Supermicro with the latest and greatest in terms of road mapping with the different CPU vendors, making sure that we have the latest and greatest to fit into that environment and to basically exceed all the other competitors in terms of bandwidth and overall performance. So jumping into that, we basically, as I mentioned earlier, we have our latest generation of our top loading. In terms of nomenclature on this latest generation, we kind of loosely call this our SP product internally, because in the product naming, if you look in that long string on the screen there, you see an SP, so 640 SP, versus the earlier generation, we would just have a P, and the P is basically the processor, the S is basically a serviceability. So the focus of this new generation was really that customer that has limited IT resources in mind. So that someone that needs to have storage server that can be managed and maintained by a minimal crew and get that best of breed serviceability out of this system so that everything is gonna work for them in terms of their operations. In our previous generation, we had 45, 60, and 90 bay models. Looking at our sales data, really the 60 and the 90 were the most popular and the ones that had the largest competitors in the market. So those were the ones that we targeted for this new redesign. And then, again, the key piece here was that serviceability, because if I have loading the server into the rack is one thing, right? We all know that with a server this size, you're going to need multiple people to get that into the rack. With this design, we've added an internal rail with a drawer style storage unit, so that essentially that mounting in the rack becomes something that's very just rigid, bolted into those standards, and no user interaction in terms of having to feed a slide rail with a 300-pound system. That's all internal, so that mechanical is very solid, internal, and no user has to line that up and mount that. Hardware, in terms of the active components, all the active components can be pulled out of this system hot. These are hot swap devices, so I can pull these nodes out in the SBB model. If I have a SBB model, I could pull out that whole node and the other node could continue to process data. Single node, obviously, you could pull it out hot, but it wouldn't be active there. So it is hot serviceable, and it is field replaceable in a modular manner. So here's another look at kind of the serviceability of those systems. So the expanders on these come out. So that's an active component that's typically soldered into the backplane on some of our lower cost top loading systems. In this case, they're removable. And then the node can come out and can be managed on a bench. So I don't have to pull the whole chassis out to do any sort of service that would be on that node. I can change DIMMs, I can change out IO cards, I can do anything that would happen on that node, and it has a connector that just plugs into the backplane. So really a serviceability model that is more closely paired with our SBD line, or you could also think of this as being kind of like our twin and big twin architectures, where you don't have to pull the chassis out to work on that server node. That modularity gives us the ability to have basically 3 configurations in 60 and 90 bays. And that's what we'll talk about in this presentation, and sort of the applications that are kind of a no-brainer fit for these 3 different configurations. So single node means I can create a very high capacity scale up architecture. A dual node is like a twin, and then the dual SBD is high availability. So we'll dig into that. So we recently published a solution brief. So if you're looking for this kind of information on to provide your customer, that's now on our top loading page. So this would have pretty much the material that I'm covering today, and with some of the examples that I'm covering today in a more generic form. So let's start off with that single node system. So the single node system, again, best of breed, we have high TDP ratings, so you can see 205 watt TDP. Typically, storage servers don't have this kind of processor support. Having that kind of process support means that we can essentially run applications converged on this node. So if someone wanted to run a Windows server on this, running an application, local database application, they could put in a processor that could do that kind of workload very easily. So really, we had that in mind in this design, that some people will want to run converged, hyper-converged, and as well as disaggregated type environments. So the single node we typically see as a converged architecture with a backup application. So you'd run a single node, you would run the backup application. So essentially the management for your backups running on this system, and then if it's backed into a cloud or any of those other things, we have plenty of bandwidth here to do that kind of networking and data movement. So this is the rear view of the single node architecture. You'll notice there is a top and a bottom tray. The top tray we call the IO NVMe tray. This has the boot drives, so I can have 2.5-inch drives on the back that I use for boot. And then it has a space for optional NVMe. So many of the software-defined architectures will want to use some NVMe for caching or tiering. Really depends on the architecture. But a lot of them will want a couple NVMe to do some offloading, to be able to do lower latency performance, to reduce that overall slowness that you'd get from a spinning drive. And then on the bottom is the actual server node. So the server node, it has 3 PCI slots. In our current generation, those are all by 16 generation 4 PCIe. So a huge amount of bandwidth available to be used in these storage systems, and that's for I/O and or for other applications. Now, we talked about those 3 different choices. So at the start, you have the server model you're going to pick, a single node, dual node, or high availability. The next point of sale selection is actually the RAID controller or the IT mode controller, the actual disk controller that you're going to use. So this is no different than our enterprise optimized, where we have our H models and our L models for that selection. So you basically decide, most of the time you'll want to ask your customer, do they need hardware RAID? It's a very simple question. It's one of what we call our SSG 101 questions. Do they need hardware RAID? The answer is yes. Then they would use this bypass mezzanine style controller. And in a single node application like backup, as an example, that might be a perfect fit, because again, we can do the hardware RAID. We offload the processor with that hardware RAID, so there's plenty of processor to run the application. IT mode, again, typically is used more typically in software defined. So things like Ceph, things like MinIO, other object storage platforms typically will use a IT mode, just because again, it's lower cost and the software defined vendor wants to have full control of access to the drives. And there are exceptions to that rule. So don't think that's the only way that a software defined architecture would be put together. So we take a little closer look at this selection here. On the hardware RAID selection, I have what we call a bypass card. So it isn't really a controller. It doesn't have the RAID controller on it. It has connectors that I put in a RAID controller. So my RAID controller then can be more flexible. I have by 16 SAS going bypass through this mezzanine card. And I also have my two NVMEs for boot applications. In this single node example, you would probably use those two NVMe drives for boot, or in a software-defined environment. Further later in this discussion with dual nodes, you might use those for caching. But really, this gives you the flexibility of configuring a controller. The default controller for this is a 3916, so that's a 16-lane Broadcom RAID controller with 8 gigs of cache. On the IT mode method, we have a much more integrated product. So this has the equivalent of two 3616 controllers on it. So that's 32 lanes of SAS. So this would be the other reason why, in terms of the software-defined vendors probably wanting to choose this, is that it has more bandwidth available to it for them to provision the storage. And it's a JBOD mode, IT mode controller, so there isn't any RAID stack available for this. It would all be done in software. And again, so this also has the two NVMEs, NVMe M.2 locations, so I can actually do boot, or I can do a caching in this controller as well. So it's really kind of a important decision when configuring the top-loading systems. So in that single node example, I show here Veeam. We talked about backup. This is very simple. Direct attached storage. I can have a very large footprint of storage with one system running Veeam on a top-loading system. And our 60 bay model in particular is a good fit here. 90 bay, typically you have to find out from the customer whether they have a rack that is 1500 millimeter depth, and typically people have 1000 millimeter racks. So the 60 bay probably is your best bet in selection for a single node backup type application server. Okay, the next model is the Twin. Now the Twin, I think it's pretty self-explanatory, but it's one of those that sometimes there's some confusion of the differentiation between a dual node Twin and what we call SBD, or a high availability setup. In the dual node twin, it's a share nothing architecture. So that top node highlighted in blue here only sees the drive bays highlighted in blue on that top view, that top down view of the storage server, and the green, only the green. So this would be two independent servers inside of a chassis. And again, there's many applications where this is a great fit. With software defined, again, there typically are rules that a vendor will set in terms of how many drives that you can attach to a system, and this would be something that would allow you to meet those design maximums with this architecture. So here's the rear view. Again, you can see that this is two of the server nodes in the back. The challenge here, of course, is that there is no rear access drive bay for you to put a boot drive. So on one of these systems, we've got a dual node. There are internal storage bays. There are 7mm bays, and there are those M.2s that you could use for that internal boot. Or, of course, you could use one of the drive bays that's in the main storage area if that's going to be easier for your customer to maintain the system and replace those drives without having to pull out the node. So the killer application that gets used with these dual node systems really is object storage and scale out infrastructure in general. So it could be object storage, it could be file, it could be block, but really a scale out architecture. Because one of the things it does for scale out is it increases that compute to disk ratio. It increases the number of network ports you have for that cluster. It increases all the resources for managing a cluster in a smaller space. So you basically get more performance per rack space, and many of the vendors, as I mentioned earlier, have limits to what they will ask for in the storage drive count. So in our 60 bay with 30 drives on each node really works well for things like Ceph, because again, it minimizes the number of drives there. And here's kind of an architectural overview. In this, I'm showing an example of a 6-node cluster, and this is in the solution brief. With a 6-node cluster, essentially it's 3 systems you're going to be buying, and that's going to equate to 6 nodes. So if we look all the way to the right-hand side, we see that the rack units required for that minimum cluster of 6 nodes, 12 rack units versus 24 if I go to a single node. So most of the traditional scale-out architectures want you to start with a reasonably good number of nodes so that you don't get into a situation where you run out of disk space, or if one of the nodes were to fail, it would stop being able to accept requests. So an example of this would be something like Ceph with data replication. If you built the actual minimum number, if one of those nodes failed, you would no longer be able to write to the cluster. You'd only have read availability. Some of the other vendors, commercial vendors, have ways around this, but in general, they will set a recommended minimum. And 6 is kind of one that kind of falls across multiple groups of software-defined vendors have 6 as the minimum. And again, another thing to look at right in the center is the ratio of the number of drives to nodes. So as you get to this higher ratio, when you have a failure, you have less compute resources to take care of that. When you have high demand, you have less compute resources to take care of it. So you can see building something on a 60 bay with 30 drives per node, if I build that architecture out, I'm always going to have more availability across the board. An example of one of our partners that is building large-scale object storage with our dual node is Quantum and their active scale product. So we again work with them, and then this is showing in terms of how you could maximize your architecture and build a very large cluster. with using the 90 bay dual node systems that they have qualified. And then finally, for our SP line with the top loading is our SBB, or high availability model. In this is traditional failover clustering. You can think of this as being, sometimes it's referred to as cluster in a box, or high availability storage controller in embedded type of storage environments. For software defined, the most commonly used platform is ZFS. So we have a number of customers building high capacity parallel file systems based on ZFS with these kinds of servers. And in terms of the architecture itself, there is an interlink between the two nodes. Typically what's used is the Ethernet connection for a heartbeat, but we also have a high-speed bus. If the software that is used to configure this system is able to use PCIe as a node-to-node interconnect, then we have that capability in this server. So most of the off-the-shelf products don't have that, but many of the OEM models or more embedded type models may be able to utilize that PCIe connection between the two nodes. This is 16 lanes of PCIe Gen 4 between the two nodes. And the other area that, this kind of storage is used and has been used for a very long time is parallel file systems, either in government applications or in oil and gas, etc. The building a very high capacity storage server on this kind of architecture is, really been changing the cost metrics. If you look at how the industry has changed from purely SAN to DAS to converged type systems, where you no longer need to be buying a disaggregated RAID connected to a storage server. You can put all of that into one of these systems that has both the CPU compute power to do a parallel file system, or to join the parallel file system, do the object storage, as well as create the data protection layer. So really this is an area that we see a number of national labs and international labs taking advantage of. An example of one of our partners that has this capability, so in terms of going out there and selling solution for a small commercial environment, would be OS Nexus. So with their QuantaStore product, it has two different architectures. It has that scale out architecture using Ceph, and it has a scale up architecture with high availability support using ZFS. So it's a real nice flexible management tool. I think of this as being kind of a federator for the storage applications that are already being used out there. ZFS and Ceph are both very popular in DevOps type environments, and popular where people are really trying to minimize their investment or the amount they spend for data protection. So this gives you that ability to manage multiple instances of these types of environments and deploy scale up techniques as well as scale out techniques. And then finally, what I want to talk about today is our roadmap. So one of the things that having two generations of top loading systems is we now can take that legacy hardware and try to improve on the overall cost. So really focus on acquisition cost. So the legacy hardware becomes essentially, we're transitioning that from a dual processor architecture to a single processor architecture, where someone is really focusing on acquisition cost as their main driver. An example of this would be something like a storage as a service vendor that really needs to drive down that cost per gig, and they can't really afford to stay in business using something with too many bells and whistles. And then when you're looking at the new top generation of top loading on the bottom here, we're really improving operational efficiency. So other groups that might not be at that same scale would be using the current or the latest generation because they don't have to have as many people in the data center, to pull out systems for service, to manage those systems becomes easier, and their operational efficiency grows with the new generation. And obviously, because these are dual processor in the new generation, the performance for applications is greatly above what would be done on the single processor units. So the single processor architecture that we have here is 45 bay and 60 bay. So it's really kind of friendly for standard rack environments, especially in terms of remote branch office or other areas where you might not have the kind of power footprint to support a 90 bay system. And from an architectural standpoint, we've been shipping the UP 45 bay. The X12 60 bay is new. So this should be shipping in volume in Q2. So if you have opportunities where maybe you've taken a look at our 60 bay and there's objection for price, and or the customer is looking for something with a little less horsepower, this 60 bay model could be a great fit. The 60 bay and the 45 bay use the same motherboard. So this is essentially a unified platform in terms of it's using a UP motherboard that's just off the shelf ATX, highly distributed, high run rate product. So it's from a traditional building block approach. These models really fit that role. So you could have a solution that has that same motherboard in a compute node, a smaller storage node, and then go all the way to these very large footprint top-loading storage servers. So in review, basically the top-loading line really is a great fit for cold and warm tier applications. The networking is very flexible. Unlike an embedded product, you basically have a lot more you can do with the software and how this runs, whether it's a converged application or whether it's just simply a target device. It can is easily configured for either of those extremes, right? We can simplify and use low bin processors, simplify networking, and create a reliable target device, or we can supersize it, put in up to 205 watt processor, and get this server working on things like cryptocurrency and having to do some compute along with that storage. So, lots of opportunity for this kind of storage server moving forward. And that's pretty much what I have for today. So at this point, we could take questions and see what's left. Okay.
Thank you, Paul. And so far, I have some questions coming up. The first one is asking, does AOM-SADPTS-S support NVMe hardware RAID?
It currently does not. We don't have any hybrid or tri-mode support on the front or on those bays. The NVMEs that would be in the single node and on the M.2s are directly connected to the PCI bus of the server, so they would be software defined. So if someone's looking for great NVMe performance, there are a number of software vendors now out there that can do extreme performance with the NVMe. But the answer in terms of that hardware RAID controller supporting a couple of NVMe? The answer is no.
Thank you. And the following question is, for NVMe for cache support, please describe briefly about this, how we can cache this.
Okay, so in I can give an example of a platform where NVMe are used in a scale-out architecture. So this would be Scality. Scality is a traditional, their product is called Ring. What they do is they will have a cluster that would be 6-node in size, is sort of their sweet spot for entry. They can actually do 3 nodes, but I would recommend in terms of the architecture using 6. They create a cache in the software. So typically it'll be 2 NVMe that they will not mirror or use any sort of RAID on the NVMe. They will have the NVMe as a storage device that holds the metadata. So it's caching the metadata to give you that extra boost in performance. So instead of having to go out and search the file structure, they have it cached on those NVMe. Another example of where you could use the NVMe are in Ceph. So in Ceph, they have a journal drive. The journal drive essentially acts as a buffer for the database table. Again, it's sort of a buffer of the database activity that's required to place the writes. So it is not technically a storage cache as much as it is a way to accelerate the database performance and improve overall latency by storing that data on those NVMe. NVMe in a other architecture such as ZFS, you can an L2 ARC for a read cache. So you could create a pool of those NVMe and use those for read caching. Essentially, so when the popular file needs to be read, it could read it out of an NVMe device, and the data protection would be done by ZFS. And so there's numerous ways that the devices themselves can be used as a cache resource.
Thank you. And I got another question which is asking, hardware RAID support is pretty limited in low latency NVMe-based solutions. It is such a big issue for OS boot and failover. Is there any other way to offer hardware RAID 1 for OS to offer senses of assurance?
So hardware RAID on NVMe, is that what it said? Hardware RAID on NVMe?
Hardware RAID support is pretty limited in low latency NVMe-based solutions. And then I guess.
Yeah. So there is a sort of a tide change happening there. The methods that will be used for hardware RAID are not the methods that you are thinking of in terms of the traditional methods. There are a good number of startups that are now starting to leverage things like GPUs and other accelerators out of band. So they're leveraging a very powerful coprocessor to do hardware, essentially amounts to hardware RAID. It's not the bridged RAID that you'd see in, say, a Broadcom controller. That obviously, because of the limited lane counts, creates a pretty serious bottleneck. Even things like VROC are fairly limited compared to some of the more advanced RAID algorithms being put out by software vendors. So an example of this would be like Radix. Radix can do extremely fast software RAID and don't really utilize much processor. So there are a number of solutions that we are investigating, but is an area that is really has started to heat up because of that that concern. The other way that traditionally or has been used is more of a cluster level, so larger scale NVMe RAID, which would be like things like WEC-IO and Accelerow. So yeah, no, definitely feel your pain. The performance of NVMe is way ahead of the performance of algorithms to protect the data, but that's sort of changing. It's starting to the guys doing those kinds of algorithms are starting to figure it out. So in our lab benchmarks, we're starting to see some really good numbers with RAID and with erasure code type data protection. Hopefully that answers that question.
Thank you, Paul. And I have another question, which I'm not sure if I can define the question, but it says, recently worked with 45-bay top-loading storage server. I was unable to open the FIM module for insert the PCIe card.
So yes, so that's one of the reasons that we suggest the next generation is, yeah, it was one of the big feedbacks we've got with our first generation was in order for us to get all of that compute into that short chassis depth, we had a lot of compacting to do and a lot of mechanicals that really impacted serviceability. So with the next generation where we've got these service modules, it takes away that problem, right? You now can remove the node and do that service. So typically the ones that have been happy with our legacy systems are the ones that are, I would describe as more concerned about the cost per gig, serviceability, customers that are deploying into standard enterprise data centers and or remote locations, remote branch office. The next generation is really the recommended platform for those environments. On our UP models, they're not quite as bad. They are more like a traditional Supermicro, open the top and you can access the PCI slots. It's a little less onerous. The 45-bay dual processor, I would have to say yes, agree that it a little bit difficult to get into those systems without getting the whole thing on a bench and removing a lot of parts. So that's was our takeaway, and it's one of the reasons why we came out with our SP line.
Thank you. And then if you have any other questions, please feel free to type to the Q&A, and then we will answer your questions. Any other questions? Okay, if not, and then that is the end of today's session. Slide and the recording will be uploaded to my Supermicro. Thank you for taking the time to join us today, and we look forward to seeing you next time. Thank you.
Thank you.
Thank you.